Today we're going to work out problem number 33 from section 7.1. So first we have our function f of x equals x to the third, and your value a equals 8. The first thing they ask you to do is to show that f is 1 to 1. And to do that, you can just show your function, and the graph of that looks like this. And as you can see, your function is always either increasing or decreasing, so you know that it's 1 to 1. Next, section B asks that you use theorem 7 to find the derivative of the inverse function of a. So theorem 7 gives you that the inverse function, or the derivative of the inverse function of a, is equal to 1 over the derivative of the inverse function of a. So the first thing you do is you find this, the inverse of a. Your a is 8, and to find the inverse of it, you take your regular function, which is f equals x to the third, and find a number x, which if plugged into this function will give you 8. As you can see, the number is 2. So when you plug in 2, you get 2 cubed, which equals 8, and so you know that the f inverse of 8 equals 2. Now you find the derivative of this. To find the derivative, you take your function f equals x to the third, and the derivative of that is 3x squared. You plug in your 2, and you get 3 times 2 squared, which equals 3 times 4, which equals 12. And so this is your denominator. And your final answer for the derivative of the inverse function of 8 is 1 over 12. Next, they ask you to calculate the inverse function of x and state the domain and range of it. So to do that, you take your given function, which is fx equals x cubed, and that's the same thing as y equals x cubed. And the first thing you do is you switch out every y to an x and every x to a y. So you get x equals y cubed. Next, you solve for y. And all you do with this is take the cubic root of x. So you have y equals cubic root of x. And that is the inverse function of x. Next, they ask you to state the domain and the range. And all you have to do with that is look at your original function, and the domain and range of that is just all real numbers. So the way the inverse function works is whatever your domain is becomes the range of your inverse function, and whatever your range is becomes the domain of your inverse function. So you know that the domain and range is just all real numbers. For part D, you're asked to calculate the derivative of the inverse function again of a, and check your answer to see that it matches with our other answer in part B. So we're supposed to use the equation that we got from C, which is that the inverse of x is just cubic root of x. And so you take that function, which is the same thing as x to the 1/3. And if you're going to find the derivative of this, you just bring this exponent down and you subtract one whole number from this power. So you get 1 minus 3 is negative 2 over 3, which is the same thing as 1 over 3 times x, or cubic root of x squared. So you're trying to find the derivative of the inverse function of a, which equals 8. So you plug 8 in, and you get 1 over 3 times cubic root of 8 squared. And from here you get 1 over 3. You know the cubic root of 8 is 2 times 2 squared, which equals 1 over 3 times 2 squared is 4, which equals 1 over 12, and matches the same answer that we got for part B. Last, they ask you to sketch the graph of f and the inverse function as well on the same axes. So here's the graph, and as said earlier, the graph of x looks like this. So this is f equals x cubed. And the way the inverse function works is every coordinate that was your x is now your y, and vice versa. So you're pretty much just rotating your graph about the line y equals x, which is this little dotted line right here. And if you're going to reflect it, sorry if I said rotate, I meant reflect. You're just going to take the mirror image of it. And this second function that I drew is your inverse